So if you Google even odd functions or look in your textbook, the definition for an even function is going to give you it should give you two different ways. It should talk about what we just did, where we're talking about the symmetry. So an even function has y-axis symmetry. Or it'll say f of x equals f of negative x. Let's see what that means. Now we just described that this guy, the parabola, was even. Well, look at what happens when you plug a value in for x. What happens when you plug 2 in for x? Well, you get 2 squared. Well, 2 squared is 4. Well, now look what happens when you plug in the same number but negative, right? F of x, but the x value is negative. Look what happens when I plug in a negative 2. It's the same number, just negative, right? So what happens when I do that? Oh, well, think about this for a second. Don't worry about calculator. If you square any number, you're always going to get a positive number, right? So it'll be negative 2 times negative 2, which is 4. Well, notice that. You get the same number. F of 2 and f of negative 2 are equal to each other. They're the same value. F of x and f of negative x are equal to each other. And you'll get that whenever your power is even. Now, if you take, remember we talked about graphically, if we move the graph left or right, it loses its y-axis symmetry, right? So if you start adding or subtracting numbers, or if it gets any more complicated than just x squared or x to an even power, then you have to think about it for a little bit. But that's the basic gist. If you plug a number in and get 4, plug in the same number but negative and get the same answer, 4, then this should be a y-axis symmetry. And what they want you to do is just plug in the x value. Find f of negative x. You plug in the negative x. Well, negative x squared is x squared, so you get the same thing. All right, but you can do that with points just as easily. Odd. Remember what we said odd was? If you Google this, look in your textbook, it's going to give you a definition basically that says if you have origin symmetry or f of x equals negative f of x. So a second ago we looked at the graph of f of x equals x cubed. And then we said that was odd. Well, look at what happens when I plug a number in. What happens when I plug a number in like 2? I'm sorry, I said that wrong. F of negative x equals negative f of x. Okay, so if I plug a 2 in, what do we get? 8. What happens when I plug a negative 2 in? Negative 2 cubed, negative 2 times itself 3 times. Negative 2 times negative 2 times negative 2. 2 times 2 is 4, and then times a negative 2 would be negative 8. Those two negatives would cancel, and you'd have one negative left over. So this value is always going to be negative. If you start with a negative, it'll always be positive if you start with a positive. So look at what happened. I didn't get that even business, right? I didn't get the part where if I plug in 2 and negative 2, I get the same number. So it's not even. But look at what happened. I plugged a negative value in and got a negative value out. This is the idea. I plugged a negative value in, and then the whole function, the whole output was negative. That's what happens when it's odd. And what they want you to do is actually just plug the value in. Plug the x in. What is f of negative x? Well, that'd be negative x cubed. Well, if you cube any kind of odd power, it's going to leave you with a negative. So you started with, you plugged in a negative, and it winds up being a negative x cubed. The whole thing turns negative. So that's how you do that algebraically. So even and odd functions, anything with any kind of function with an even power. All right, that's your common function that you start with. The absolute value, remember what that looks like? It looks like a v. So that has y-axis symmetry. That's even. 1 over x to an even power, like 1 over x squared, 1 over x to the fourth. That has y-axis symmetry. Okay, odd functions, just plain Jane f of x equals x. Now, that's just a line going through the origin. Okay, f of x to an odd power, like x cubed, x to the 5th, x to the 7th, which is this guy, right? And then 1 over x to an odd power is going to be this guy. And it has origin symmetry. So those are your common functions denoted as even or odd. All right. So let's look at some examples here. What would this be? Well, if I graph this, I know this is going to be. I do this for a living, so I can actually graph that without in my mind. You know, I'm that good, but I'm not expecting you to be that way. But remember, if we graph this as -4 as your y-intercept, and use your slope 3 over 1. This is linear, so I know to graph it this way. So 3 over 1, 1, 2, 3 over 1. Let's think about this. This has no y-axis symmetry. If I took this point and reflected over the y-axis, I'd mop back on the graph. Not even. To be odd, it has to be, I have to reflect it over the y and then over the x and be back on the graph, which is not. It's not that way. It has to go through the origin to be odd as well. So this is neither. Okay. Now, algebraically, remember what we're supposed to prove? If you plug a negative x in, you get a negative function. So if I plug a negative x in, what happens? Well, that just is going to be -3x. Oops, -4. That is not. That's not the same as having a negative out in front of this. Right? If you plug negative x in, you're supposed to get a negative function, which is -3x minus 4. Well, if I distribute the negative, I get -3x plus 4, which is not the same. Okay? If we did it with a point, what happens when I plug in a -2? I get -10. What happens when I plug in a +2? I get 2. So remember, this is not even, right? You don't wind up with the same number, but with the same number, so it's not even. Okay. So I like to look at these things graphically, but you can also prove them algebraically using just plugging in an x value. Okay. What was the next one we're going to look at? G of x equals 3x squared minus 4. What would this be? Well, I see x squared, so I'm thinking this is, if it's anything, it's even. If it's anything, it's even. So if I think about this for a second, x squared is this guy, and the 3 is just going to make it a lot skinnier. The 3 in front of it is just going to make it a lot skinnier. And then the -4 is going to move it down 4 notches. So I did not move it left or right any. I did not move it left or right any. So that means I did not lose my y-axis symmetry. So it is still has y-axis symmetry, so it is even. Okay, but what you're supposed to do is you're supposed to see if f of x equals f of -x. If you plug a negative x into the function, you're supposed to get the original function back out. So let's see what happens. Well, what happens is we're going to square the x value, and if you square anything, you always get a positive answer. And that's exactly what we started with. So this is even. This is even. Okay, now, h of x equals 3x squared minus 4x. I'm not so sure about how to graph this one. I mean, I could graph the last one because it had a parent graph, but this -4x business is throwing me off. What I do know is that, well, I could complete the square and do all that business, but you know, who's got time for that? So let's just graph it, see what it looks like. Windows all jacked up. Oh, we'll see here. It's the whole parabola's been shifted off the y-axis. The y-axis is no longer the line of symmetry. Right? It's not symmetrical about the y-axis anymore. This is not even. The only chance it had was to be even, and in this case, it's not. Right? This said that it could have been even, but if I look at the graph of it, it's not even. Right? It does not. There's no axis symmetry. There's no origin symmetry. Therefore, neither. Therefore, it's neither. And if you want to check it out, so this is the one I want to. X squared, that's the one, it's the only opposite option you had, so you want to check to see if this is correct. So you'd say, you plug in negative x and see if you get the same thing back out. You plug in negative x in. Notice how I'm putting parentheses around these, right? Okay, and well, what would happen here? You get a positive x squared, right? X, okay, now negative 4 times negative x is a positive 4x. Ah, there's the difference, right? There's the difference. It's not exactly the same thing that you started with. So it's not going to be origin. It's not going to be even, and it didn't wind up changing all the signs, so it's not odd. So it's neither. So I prefer the graphic method, but hey, choose your own.